Hello everyone, we're learning number system and today we will see how to convert decimal numbers to binary numbers. Previously we have learned about these two types of number system. Okay, here is a question. Convert the decimal number 13 into its binary equivalent. So we will see how to convert it. Look into it very carefully so that you don't miss any step. Let's see how to solve it. We will be using divide by 2 method. That means we have to divide the number by 2. Okay, you have been doing this method in your maths. And we also know that the base of decimal is 10 and the base of binary is 2. We have learned about this before. So what we will do to convert decimal to binary is we will use the divide by 2 method. Let us write down it also as base 10, which is a decimal number, and we have to find base 2, which will be binary. Okay, so this is the question and we're just writing down what we have to find. Let's see how to do it. Let us write down the number that is given, and like I said, we will be using divide by 2 method. So we will divide 13 by 2. How many times will it be? There will be a remainder. Okay, so what we will be doing here is we will divide 13 by 2. 2 6 are 12, right? 13 cannot be divided by 2. So 2 6 are 12, 1 is left, and so we'll just write that there is a remainder, that is 1. 1 is a remainder. Now you remember that the decimal numbers, right, have base 10. That means 0 to 9. The numbers can be 0 to 9. But binary numbers can have only 2 digits, that is 1 and 0 or 0 and 1. Okay, like I'm writing here, the quotient here is represented by Q, and that is 6. 2 6 are 13, so that is the quotient. And remainder, 2 6 are 12, so 1 will be remaining and 1 is the remainder. Now remember that this first digit that we get, okay, is termed as LSB. Okay, now what is this LSB? It's not a very complicated term. Okay, it's very simple. Now this LSB stands for least significant bit. Okay, least significant bit. This LSB stands for least significant bit. And when we arrange these binary digits, that is 1 and 0, this LSB should be the right hand side, should be the rightmost side. Okay, the rightmost side. For example, let's say the binary number is 10101. So which is the rightmost side? That one, right, which you see on your screen. And that one on the rightmost side is termed as LSB, least significant bit. Okay, so the first remainder, either it is 1 or a complete division, which will be 0, the first digit that we'll be getting when we are solving it will be the LSB, the least significant bit, which will be placed on the rightmost side. Okay, so let us continue dividing this by 2. How much should we divide it with? 2 3s are 6, right? So there is no remainder. So remainder will be 0. No remainder refers to, it will be 0 because binary will be using 2 numbers. Okay, so we can say that the remainder is 0. And the quotient here is 2 3s are 6, so 3 is the quotient. We'll just represent quotient by capital Q. Q is equal to 3, and R, which is remainder, is equal to 0. I hope you have understood this. Now let us continue dividing it. 2, we can't perfectly divide 3, right? So 2 1s are 2, and there will be one remainder, right? So remainder is 1. And what is the quotient here? Quotient is 1, and remainder is also 1, right? I hope you are understanding this. Now we do not actually need quotient to write down the binary digits, okay? I'm just writing here to make you understand it much better. Now 1 cannot be divided by 2, so we'll do it with 0. Okay, now when we multiply 2 with 0, there will be one remainder left, and that remainder will be 1. Always keep this in your mind. Okay, when we are multiplying 2 with 0, there will be a remainder left, that will be 1. Now this last digit that we get, okay, when after we multiply 2 with 0, that last digit is termed as MSB. Now what does MSB stand for? It stands for most significant bit. Okay, that stands for most significant bit. And I guess you understand this, that where will it be placed? For example, 101 101. Now this is the leftmost side of the set of digits in binary number system. Okay, the leftmost side, like you can see on your screen, I have marked it there. The leftmost side digit is termed as the MSB, which is most significant bit, and the rightmost side digit is termed as LSB. Okay, so let's see how can we write it down. We have to write it from MSB to LSB. Okay, remember this order in which we'll be writing. You can see the arrow sign. How should we be writing? We should not be writing from up to down. Okay, in simple words, we should be writing from the last digit, that is the digit below, till the digit that is above. So what do we get here? 1101. All right, therefore 32 base 10, that is decimal number, is equal to 1101 base 2, which is a binary number. It's quite simple, right? And I hope you have understood this. We will see some more examples so that you can understand it much better. All right, you can just go back through the video and see it again. Let's see another example here. Convert the decimal number 32 into its binary equivalent. It's very simple, right? Let us write down the number. We'll be using divide by 2 method. So we'll divide 32 by 2. 2 16s are 32. So R is equal to 0. There's no remainder. Let's continue dividing it by 2. 2 8s are 16. So again, we do not have a remainder left. So, or a remainder is 0. That's better to say. Remainder is 0. Let's continue dividing by 2. 2 4s are 8. In this step also, R is equal to 0. 2 2s are 4. Right, in this step also R is equal to 0. And the next step is 2 1s are 2, where R is again equal to 0. The remainder is 0. Now we cannot leave that 1 alone. We have to divide, or we have to multiply 2 into 0. Okay, or we have to divide 1 by 2. So in that case, we have to multiply 2 with 0. And whenever this happens, I told you that R will be 1. Okay, so the first digit that we found, which is 0, remainder 0, that is what? That is the LSB. Okay, the rightmost side. And the last digit that we got. Okay, let me just write it down for you. If you have forgotten, you can recall it. Rightmost side. Okay, and the full form of LSB is least significant bit. And the last digit that we found, that is remainder 1, that is termed as MSB. Okay, which will be the digit on the leftmost side. Now the full form of MSB is what? I hope you remember it. Alright, it's the most significant bit. And in what order do we write these digits? From below to the top. So let us arrange these digits and we will get the answer as the binary equivalent of 32 decimal number. So how much do we get? Is it 1 lakh? Yes. We do not say it as 1 lakh. We will call it as 100000. Okay, remember, we will not call it as 1 lakh because we will count it individually, 1 and 0. So here 32 base 10 is equal to 10000002. That is binary. Right? I hope you have understood this. Now let us see how to convert binary numbers to decimal numbers. We have learned how to convert decimal, that is base 10, to binary number, that is base 2. Now we'll see how to convert binary numbers to decimal numbers. A little basic before we start solving a problem. Now binary uses only 2 digits, right? You know that. And those 2 digits are 0 and 1. And we also know that binary is of base 2. Now this is what I want you to remember. You have learned this in mathematics. Okay, that was the placeholder in decimal number system, in number system. Now the placeholders in binary has powers of 2. For example, 2 to the power 1 and 2 to the power 0, which is 2 naught. Okay, I hope you understand that. So the first place has a value of 2 naught, which will be equal to 1, right? 2 naught is 1. The second place has a value 2 to the power 1, which will be 2. Third place has a value 2 to the power 2, okay, which is 4. 1 to 4. Remember these numbers 1 to 4, they represents bits, okay, and bit represents the memory space in which numbers or any data is stored in the computer. That's what we are learning now. Fourth place has a value 2 to the power 3, which is equal to 8. So and so on. So here we have learned 1 2 4 8 bits, and when the digits are of this place value, it uses that many bits of space. Like for example 10011101, we have learned about this. The leftmost side digit, that is termed as MSB, which is most significant bit, and the rightmost side, okay, that is termed as LSB, that is the rightmost side. And so when you, after solving, when you'll be writing down these digits, do not get confused which one is to be written first and which is to be written last. Okay, you have to remember this MSB and LSB. It will be very easy for you to know how to write down or how to arrange the binary numbers. Okay, so MSB stands for most significant bit and LSB stands for least significant bit. And I think you have got this in your mind, right? And I hope you will not forget this. Let us see how to convert this. 110101. Now this is binary, so we write it as base 2, and we have to convert this to decimal equivalent, which is base 10. Okay, and you know that the leftmost side digit is termed as MSB and the rightmost side digit is termed as LSB. Okay, I have just mentioned it here so that you remember it. Now let us write it down according to its place position, starting from the LSB. 1 into 2 to the power 0. Okay, the next digit is 0, so 0 into 2 to the power 1, plus the third digit is 1, so we write it as 1 into 2 to the power 2. The fourth digit is 0, that is 0 into 2 to the power 3, and the fifth digit from the right to left is 1, so we'll multiply it with 2 to the power 4, and the last or the most significant bit, the digit is 1, so we multiply that digit with 2 to the power 5. So this is the arrangement that we have found. Now what we'll do is we'll further solve it. 2 to the power 5 will be how much? 2 to the power 5 is 32, so 32 into 1 will be 32, plus 2 to the power 4 will be, we have to multiply 2 4 times, that will be 16, and 16 into 1 is 16, plus any number when we multiply with 0 will give us 0. Okay, plus 2 to the power 2 is 4, plus 0 into 2 to the power 1 will be 0, plus 1 to 2 to the power 0, or 2 naught. 2 naught will always be 1. 2 naught will always be 1. You remember that whenever there is a value with naught, okay, the result is 1. Now our next step is to add these numbers that we have just calculated, and when we add these numbers, 13 plus 16 plus 4 plus 1, we will get it as 53. So this is decimal equivalent number of the binary number that was given to us as question. So therefore 110101 binary is equal to 53 decimal, or 53 base 10. I hope you have understood this. It's not very complicated, it's easy. You can go back through the video and see it again, understand it, learn, and like I always say, keep practicing, okay, and keep learning.